Hello everyone, this is the fifth worksheet on hypothesis test, and this one is a set of exercises for hypothesis test for one population mean when sigma, or the population standard deviation, is unknown. Okay, now the first couple of problems are similar to the ones that we worked in when the sigma was known in the previous worksheet, except that this is a t-test procedure instead of a z-test procedure because the sigma is unknown, right? So what I'm going to do is I will skip the first one. This is a straightforward problem, really. They have given us all the data sets we will need upfront to work on this hypothesis test. This is a left tail test, as you can see. So the first one I want you to complete by yourselves, all right? The second one I'll walk through that, and then there is a word problem, application-based word problem, the last problem in this worksheet. I'll work through that as well, right? So number 2, well, let's go back and see what they're asking here. It says we have provided a sample mean, sample size, and sample standard deviation. In each case, use the one mean t-test to perform the required hypothesis test at the 5% significance level. So we are going to work these using the 5% significance level. Now let's go back to question number 2. Here the sample mean given to us is 24, and the sample size is 15. S equals 4. So S is the sample standard deviation. Obviously we do not know the sigma value, the population standard deviation, so we don't have any other option but to use the sample standard deviation, which is 4. And they have stated the null and alternate hypothesis for us. So the null hypothesis is mu equals 22, and alternate hypothesis is mu is greater than 22. The first part of it is state the null and alternate hypothesis. Just write the null hypothesis as is. So let me take out my pen here. The null hypothesis is null hypothesis colon mu equals 22. And the alternate hypothesis is colon mu greater than 22. Now, because it's greater than 22, the alternate hypothesis decides if the test is going to be a left tail test or a right tail test or a two tail test. All right, so this symbol here is the greater than symbol. So it's going to be a right tail test, correct? So the type of test is going to be right tail test, right tailed. And also the procedure we are going to use is the t-test procedure. Just because we do not know the sigma, we have to use our S. Determine the significance level you are testing at. So it's going to be alpha equals 0.05, which comes from the significance level, 5% significance level that we are testing at. Part D says draw a diagram showing rejection and non-rejection regions based on alpha. Let's quickly do that. Yeah. So we have our normal curve. This is our normal curve, and we will have our null hypothesis mean at the center. So null hypothesis mean of 22, right? The null hypothesis mean is 22, so that value is going to be the center point. Because it's a right tail test, the rejection region will be to the right, so it's going to be reject on the right, and do not reject, all right, DNR, do not reject on the left hand side, on the other side of reject. Now the area associated with the reject region, this area is going to be whatever value alpha is. So it's 0.05. That's the alpha value. That's the probability of rejecting a true null hypothesis. In other words, the probability of making a type 1 error. Okay, so we have our rejection and the do not rejection regions laid out here. We will need to find the critical value, that is the cutoff between the reject and the DNR, do not reject regions. All right, again, keep in mind that the critical value is going to be a t value this time. All right, not a z value. It's going to be a t value. So it's going to be t of 0.05. It's on the right hand side, so it's going to be a positive t value, but the t values always come with a df, or degrees of freedom. So there's going to be certain degrees of freedom, which is derived again from n. So df, all right, df is n minus 1, which is going to be 15 minus 1, which is 14. All right, 15, n is being 15. The degrees of freedom will be 15 minus 1, which is 14. Now, part E says calculate the test statistic. Now, the test statistics is calculated using the sample data and the formula for the t score, correct? And the formula is, again, you can find that in your formula sheet. But I have it memorized, and after solving a few problems and using the t-test formula, you will also kind of remember it by heart. So t is equal to x bar minus mu, which is the same as the z value, the numerator part, and in the denominator it'll be s divided by square root over n, not sigma but s. So x bar given to us is 24 and mu is 22. That's the null hypothesis mean. That's minus 22 over s has a value of 4, right? This is our s. So 4 divided by square root over 15. That's what n is. So square root over 15. All right. And then the numerator 24 minus 22 is a 2, and 4 divided by square root over 15 comes to 1.032, and then when we do this division we should get a value of 1.938 for our test statistic value. And the test statistic is denoted by t sub 0, all right, or z sub 0. That's how the test statistic is normally denoted. So we got our test statistic. Now part F says perform the test by critical value approach and p-value approach and state the decision. So critical value approach involves the rejection and do not reject regions. So let's just start with drawing the same diagram pretty much that we drew in part D. But we have to have it in front of us. So this is our curve. A normal probability, it's also called a normal probability curve or a normal curve. And the center point is going to be the null hypothesis mean, right? Mu sub 0 equals 22, which will have a t value of 0. And then the rejection region is to the right because it's a right tail test. Let me use a different color. So this is our reject. Then the do not reject region is to the left side, so the other side of reject, and the area corresponding to the reject region is 0.05. So we have to find, now this is a t-test, not a z-test, so we have to remember to find a t value. So it's going to be t of 0.05, and the df, let's write that first. So df is 15 minus 1 equals 14. So the critical value of t of, well, the critical value is t of 0.05 with df equals 14 will be equal to, now we have to go back to our table, the t table this time, and find the critical value, the t value. So let's do that. So here's our t table, and we are looking for a df of 14, right? We calculated our df as 14 from 15 minus 1, and minus 1, 15. So this is the row that we should be looking at. And let me just make this narrower. Okay, and it's t of 0.05. So t of 0.05 with df of 14 is 1.761. So let's go back to our worksheet here. So it's 1.761, correct? So let's get our pen out. It's 1.761. That's our cutoff. 1.761. 1.761. This, the t value, the cutoff point between the reject and the do not reject regions. So now we check, we bring our t sub 0 value, which was 1.938. So our t sub 0, test statistic or t sub 0 is 1.938, and 1.938 is greater than 1.761. And please show that on your diagram too. It'll fall somewhere to the right, being greater than 1.761. It'll fall somewhere to the right of the cutoff, the critical value. That's where 1.938 is. It falls in the reject region. So it falls in reject region. Therefore, the decision should be to reject the null hypothesis. Reject null hypothesis. However, we have to also perform the test using the p-value approach. And for the p-value approach, we will have to start with our test statistic value, t sub 0. So t sub 0 equals 1.938 of df equals 14. All right, we have to find the area, the probability really, which corresponds to the area to the right of this value, wherever this value is located on the normal curve. So let's draw a picture here. We have again the normal curve. Now this time for the p-value approach, we do not have to show reject regions and do not reject regions. All we do is with 0 being at the center, we show where 1.938 is, it will be somewhere to the right of the center point. So let's say this is 1.938. That's our test statistic value. Let's just lengthen the line to touch the curve. And this area to the right is going to be the p-value. It will represent the probability of finding a test statistic of 1.938, assuming that the null hypothesis mean is true. All right, so this area is what we are finding. That's a region of interest. Now, if you're using a calculator, a graphing calculator with a statistical package in it, then you will find that this p-value is 0.036. right, from the calculator, the exact value. However, if you are using the table, then it'll be an estimated value, an estimated value. So let me go to the table and quickly show you how to come up with that. So our DF is still 14, which is this one here. Let me use a different color this time. This one, right? This is our DF row. And what was the value? It was, the T value was 1.938. So 1.938, if you look at these T values, the different T values along this row, then the T values are increasing from left to right. The first one is 1.345, 1.761, then we have a 2.145. So you have to see between which values or where on this row the particular test statistic value would fit. Our test statistic value is 1.938, and that would fit, let me just, one more time. All right, 1.938 would fit somewhere between 1.761 and 2.145. It'll be somewhere over here, right? That's where it will fit. Now we have to find the 1.938 between these two values, 38. Now, just a second, let me just write this a little better. Maybe I should remove this. All right, so yeah, it's going to fall between 1.761 and 2.145. That's where 1.938 is going to be. And we have to now look at these alpha values. All right, so for 1.761, the alpha value is 0.05, and for 2.145, the alpha value is 0.025. So 1.938 being between these two values, the corresponding p-value would be a value between 0.05 and 0.025. So if you look at all these alpha values, as we go from the left to the right, the alpha values are dropping, right? The first one is 0.10, then we have a 0.05, 0.025, 0.01, and 0.005. All right, so the p-value is going to be less than 0.05 but greater than 0.025. All right, so it's going to be an estimate. If you're using the table, then you will not know the exact value because this is a truncated table. This is not for every alpha value out there. Okay, only for the special alpha values. But if you're using a graphing calculator, you will be able to get the exact value. So if you're using the table, then the way you're going to write your p-value is like this. All right, so this is the p-value. The actual p-value is 0.036 using the calculator, but with the table, if you're finding it with the table, you have to write p-value, or rather, let me do this here. Okay, the p-value is a value which is going to be greater than 0.025. 0.025 less than p means p is greater than 0.025, but it's going to be less than 0.05, which makes it a value between these two alphas, right? And as we can see, 0.036, which we found from our calculators, is a value between 0.025, is a value which is greater than 0.025 and a value less than 0.05. So it kind of fits this, all right? So now that we know that p is 0.036, or it is a value between these two alphas, we have to compare p with alpha. All right, so the question is p less than alpha? So alpha value is 0.05, and p-value is 0.036. It is less, all right, it's true. Okay, it's less than that, so oops, it's jumping around, so just give me a moment here and let me rewrite this. 0.036 is less than 0.05, so that's true, it is less, and if it is less, then we reject, therefore reject null hypothesis. Okay, so the interpretation is at the 5% significance level, and that's how you should start the interpretation, by qualifying it with its significance level at which we are testing. At the 5% significance level, the data, since we are rejecting it, we are going to say the data do provide sufficient evidence to conclude that the population mean is greater than 22. Now, because this is a straightforward problem, because this is not an application-based problem, we cannot interpret it in context of that application situation. But so we just have to say that it provides sufficient evidence to conclude that the population mean is greater than 22. That's whatever the alternate hypothesis states. Okay. Now, question number 3 is an application-based problem that you will be using the t-test procedure. Now, in an application-based word problem, the main exercise is to understand what it is about and from the wordings extract the appropriate data, and then also be able to state our alternate null and alternate hypothesis. So first, let's read through it, and we may have to reread it a few times to get all the information out of it. So here it says, death rolls. Alligators perform a springing maneuver referred to as a death roll to subdue their prey. F. Fish et al. Performed a study to measure the degree of the angle between the head and body of the alligator while performing the roll. A sample of 20 rolls yielded the following data in degrees. So here is the set of data. We have 20 data points here, right? 5 times 4, 20 data points given to us. So n is going to be 20. That's what it means. And then here it says at the 5% significance level, do the data provide sufficient evidence to conclude that, on average, the angle between the body and the head of an alligator during a death roll is greater than 45 degrees? And they've given us some additional data points. They said that the sample mean is 49.0 degrees, and S, which is the sample standard deviation, is 10 degrees. Now, the fact that they've given us S immediately tells us that this is going to be a t-test procedure, correct? The population standard deviation is nowhere to be found here, but they've given us the sample standard deviation, so we have to use the t-test procedure. But first, let's go back and understand what this word problem is about. It says that alligators, when they capture their prey, to subdue them, they move their head at an angle to their body to subdue the prey, to bring the prey under control. So scientists, biologists, they measured that angle and then they listed them for 20 rolls. The whole procedure, that whole maneuver is called death roll, because that way they can control their prey and eventually subdue it and kill it. So that whole maneuver, they have collected all this data, and these are the angle data, the angle in degrees, right? So we have to perform a study to see if the death roll, that angle, is greater than 45 degrees based on this sample study, right? So in order to extract the data, like I always say, the best thing is to write the formula that we will need for our test statistic. All right, if you're working on a confidence interval, have the formula for the confidence interval in front of you. That way you will know which variables you will need the data for. All right, otherwise, unless you have all the data that is needed in the formula, you will not be able to perform the calculation. Now, this is a t-test procedure, so we are going to have to find the test statistic, the t-value. All right, so let me write that down. It's going to be t equals x bar minus mu over s divided by square root over n. Now let's see which of these variables and their data is given to us. So first, here it says x bar equals 49. All right, so x bar equals 49, x bar being the sample standard deviation, and that was really calculated by adding up all these 20 data points and dividing it by n, which is 20, correct? That's how we find our sample mean, sigma x. All right, this comes from the formula sigma x divided by n, but they have done the calculation for us, so we are just going to use that. Then we have S, right? S given to us as 10 degrees, 10.0, and N is 20, correct? N equals 20. Now we have to find the mu. Now this mu or mu sub 0 is the null hypothesis mean. It's the null hypothesis mean. So let's see what that value would be. What's the null hypothesis mean? Because that's not given to us. It's not obvious to us yet. So I'm going to go back and reread the wording where it says, at the 5% significance level, do the data provide sufficient evidence to conclude that on average, the angle between the body and the head during a death roll is greater than 45 degrees. So the 45 degrees represents our null hypothesis mean, right? So I'm going to write that mu sub 0 is 45 degrees. So now we have all the data we need to perform this calculation of the test statistic for t. So we can go ahead and start working on the steps, right? There are 6 steps to performing a hypothesis test. Starts with stating the hypothesis. So step 1 is state your hypothesis. State the hypothesis. State the hypothesis. So null hypothesis, the null hypothesis will say mu, the population mean. All right, null hypothesis must always be stated in terms of the population mean. So mu equals, it should always have an equal sign, and then the 45 degrees. That's the null hypothesis statement. That's probably the most observed angle, all right, of these death roll that has been observed, but we want to see whether that is true or not. Okay, the alternate hypothesis colon will say mu equals, well, not mu equals, I'm sorry about that. It's going to say mu and then 45. It's going to have the 45 degrees on the other side, but what should we use? All right. Equals belongs to null hypothesis. All right. So we have to put a sign here, all right, between this mu and 45 degrees and the alternate hypothesis. And that's going to again come from the wording. So again, let's reread the question. At the 5% significance level, do the data provide sufficient evidence to conclude that on average, the angle during a death roll is greater than 45 degrees, right? So this is the word here, greater than, is what tells us the sign we should put in the alternate hypothesis statement. So it should be the greater than sign. And as soon as we put this greater than sign in the alternate hypothesis, that will tell us it's going to be a right tail test. All right. If it is a greater than in the alternate hypothesis, it's going to be a right tail test. So now we've completed step 1. Step 2 is to determine the significance level or the alpha value. All right, significance level or alpha value. So alpha here comes from the significance level, which is 5%, but alpha value is a decimal. It's the decimal version of that 5%. So that's 0.05. So we got our step 2 now. In step 3, we will need to find our test statistic, which is our evidence that comes from the data, from our sample data, right? So calculate the test statistic. So that's step 3, test statistic. And our test statistic is T. So the formula is T equals X bar minus mu over S. Hold on 1 second. This is moving around. So let me rewrite this again. All right. So it's T equals X bar minus mu over S divided by square root over N. Let's plug in the values. X bar is 49. Mu is 45. So here's all our data, right? All this is our data. And then divided by S is 10 divided by square root over 20. So that's going to be 4 divided by 2.24 is what the denominator comes to when we divide 10 by square root over 20. And we end up with a test statistic value of 1.786. That's T sub 0. All right. Now, that completes step 3. In step 4, we are going to use our 2 approaches to help us come to a decision. The first one is the critical value approach. The critical value approach, where we have to first set up a diagram and show our reject and do not reject regions, correct? So let's draw our normal curve. Here's our normal curve. And we place the null hypothesis mean at the center of this curve, which is 45, right? 45. And that translates to 0 for the t value. So that's 0. And then the rejection, do not rejection regions. It's a right-tailed test. The right-tailed test means the rejection region is going to be to the right. So this is reject on the right end of the curve, and the other side of the reject is going to be the do not reject region. And then this area under the curve, which falls under the reject region, is whatever the alpha value is. So it's 0.05. So we have to first find the critical value, which is the cutoff, this point here on the horizontal line. It's a t value, because it's a t-test procedure, it's going to be a t-value. So it's going to be the t of whatever this area is. So t of 0.05. But we need another parameter here, which is called the df. All right. So with df equals, what is the df? Let's calculate that. Now, df, again, hold on one second. The writing is kind of playing around with me. So df equals, now the formula for the df, so let's do the calculation. Df equals n minus 1, all right, which is 20 minus 1 gives us a df value of 19, all right. So df is 19. So I'm going to write here t of 0.05 with df 19. Now we have to look up that value in our table or from your calculators. So CV, all right, CV is t of 0.05 with df equals 19. Let's go to our table. All right, so where's my table? Here's my t table. We have to go to where 19 is, right here, and t of 0.05, all right, t of 0.05 for 19. Let me just, for 19 is 1.729 here, this value here, 1.729. That's our t, the t value, the critical value, so to speak. So let's go back. Just a second. 1.729. To pull up my pencil again. So CV is 1.729 from the table. But you should get the same value if you're using a graphing calculator with a statistical package. All right, so now that we found our CV, which is, let me write that, 1.729, 1.729, that's our critical value. We have to bring our test statistic, the evidence, right? And we see where it falls in this diagram. Does it fall in the reject region or in the do not reject region? So we see that 1.786 is really greater than 1.729. So it will be somewhere here to the right of 1.729, slightly to the right, but it still falls in the reject region. That's where 1.786 would be. All right, that's the reject region. So let's write that clearly. Falls. All right, so that's the t sub 0, the evidence falls in reject region. So in step 5, we are going to say, that reject the null hypothesis. That's going to be our decision, but you have to explain clearly how you came up with this decision. So this figure is necessary, showing all the all the markings here, which is the reject, which is the do not reject, and where the critical value and what the critical value is. Show your work here, and then also explain why you say that it falls in the reject region. All right, now we also have to do the same test using the p-value approach, correct? So let me just separate this. So for the p-value approach, we start off with our test statistic value. Okay, we start off with our test statistic value. Again, bear with me please here. So that's the p-value approach. where we take our test statistic t sub 0 of 1.786, all right, and find area to the right. Because this is a right-tailed test, therefore the area that we are looking for is to the right of wherever 1.786 falls in our diagram, in our norm T curve. All right, so find area to the right, but we need that DF value as well. So it's T sub 0 of 1.786 with DF. So we need to write that as well. So let me rewrite this. T sub 0 equals let me do it a little bit differently. T sub 0 with, all right, T sub 0 with DF equals 19 is, which one is it? It's 1.786, 1.786. So we take this T sub 0 value and find area to the right of wherever this is located. So let me quickly again draw our curve. Okay, so let's say this is a T curve. And 1.786, if this is our center point, all right, the center point is here, 0. 1.786 will be located to the right. It's almost close to 2. So let's say somewhere here, this 1.786. Extend this line here vertically up, and this is the area we are looking for. All right, that's going to be our p-value area. And why are we looking at the area to the right? Just because this is a right-tailed test. All right, right-tailed test. So I'm going to go, again, we have to keep in mind that our DF is 19 before we go to the table. Now, if you're using a calculator, you will get the exact p-value there, and that is going to be 0.045. All right, so from a calculator, P equals 0.045. All right, but I'm also going to show you how to estimate it from the table. Again, the table, you cannot find the exact value from the table, but you should be able to get an estimate which should kind of confirm that it's going to be around this value. So let's go there. All right, so 19, again we are looking up this row. Okay, 19, this row, and then it's 1.786. 1.786 is going to be a value between 1.729 and 2.093, correct? It's going to be a value between an alpha value between these two t values. So let's put it here. 1.786 will lie somewhere between these two t values. Now let's look at our alpha values, corresponding alpha values. For 1.729, it's 0. Oops, sorry about that. Okay, so 1.786 we said would fall between 1.729 and 2.093. This is where it would be located, but the alpha values is what we are interested in. So the p-value would be a value between 0.05 and 0.025. All right, so, and we know that the 0.045 that we found from our calculator is a value between these two alphas, correct? So the way I'm going to write this is, let's do that. From our table, 0.025 is less than the p-value and greater than and P is greater than 0. Sorry, let me restate this. So 0.025 is less than P, and P is less than 0.05, and that matches with what we got from our calculators, the exact value, which is 0.045. So now that we have our P value, the next step is compare P with alpha. The question is P less than alpha? Yes. So we have 0.045 for our P. 0.045 is indeed less than 0.05. That's true. And when P is less than alpha, we take the decision to reject our null hypothesis. So both our approaches gave us the same decision. So step 5 is reject null hypothesis. That's confirmed. Step 6 is to interpret it, right? So it's the interpretation where we start off by saying that at the 5% significance level, the data do provide. So when it is a reject decision, that means our evidence was strong enough to reject the null hypothesis. So we have to say the data do provide sufficient evidence to conclude that on average, the rest of it you can just take the verbiage from the question. All right, everything after conclude. On average, the angle between the body and the head of an alligator during a death roll is greater than 45 degrees. To conclude that on average, the angle between the head and the body of an alligator during the death roll is greater than 45 degrees. So that's a complete interpretation. All right, so just work on these hypothesis tests on your own and just use this as a guide. All right, just to cross check your work. You do need to complete all these worksheet questions yourselves first. All right, and then just come back and check against the solutions.